Welcome to this lesson on healthcare math, focused on the conversions you will use again and again in clinical practice. Numbers are everywhere in patient care. We record temperatures, weights, heights, medication amounts, and fluid volumes, and these often come in two different measurement systems. A patient may tell you their weight in pounds while the medication is dosed in kilograms, or a thermometer may be read in Fahrenheit while the chart uses Celsius. Being able to move smoothly and accurately between the units is a core skill, and it matters for safety. A small slip, like a misplaced decimal or dividing when you should multiply, can change a dose or a recorded value in ways that affect a patient. In this lesson, we will build a simple, reliable method for any conversion, then work through the most common ones: Fahrenheit and Celsius, pounds and kilograms, milligrams and grams, milliliters, cc's, and drops, centimeters and inches to feet and inches. For each, you will see the formula and a worked example you can follow. 2 habits will carry you through all of them. Always label your units and always estimate whether your answer makes sense before you write it down. By the end of this lesson, you should be able to do the following. First, use a simple, consistent method to set up any unit conversion, keeping your units labeled. Second, convert temperatures between Fahrenheit and Celsius using the correct formulas. Third, convert weight between pounds and kilograms, which you will use for dosing and charting. Fourth, work within the metric system to convert between milligrams and grams and understand milliliters, cc's, and drops for volumes. Fifth, convert length between centimeters and inches and express inches as feet and inches. Finally, recognize and avoid the most common conversion errors, especially decimal mistakes. Keep in mind that none of this requires advanced math. It's mostly multiplying or dividing by a known factor and then checking if your answer is reasonable. The goal is accuracy and confidence so that when a conversion comes up in the middle of a busy day, you can do it correctly without second guessing yourself. Before we tackle specific conversions, let's set up a method that works for all of them. Every conversion uses a conversion factor, which is just a known relationship between two units, such as 1 inch equals 2.54 centimeters or 1 kilogram equals 2.2 pounds. The whole task is deciding whether to multiply or divide by that factor. Here's a reliable way to think about it. Write down what you have with its unit and what you want with its unit. Then ask, am I going to a larger unit or a smaller unit? If you're converting to a smaller unit, you will usually have more of them, so you multiply. If you are converting to a larger unit, you will have fewer of them, so you divide. Always keep the units written next to the numbers because the unit tells you whether your setup makes sense. The last and most important step is to estimate. Before you trust the number, ask whether it's reasonable. If you convert 70 kilograms to pounds and get 32, that should feel wrong because a kilogram is bigger than a pound. So the pound number should be larger, around 154. Labeling units and sanity checking your answers will catch most mistakes before they reach the chart. Let's start with temperature, Fahrenheit and Celsius. Clinical settings may use either, so you need both directions. To go from Fahrenheit to Celsius, subtract 32, then multiply by 5/9. To go from Celsius to Fahrenheit, multiply by 9/5, then add 32. The order of operations matters, so follow it carefully. A helpful anchor to memorize is normal body temperature. 37 degrees Celsius equals 98.6 degrees Fahrenheit. If your converted value lands far from what you expect for a body temperature, that is a clue to recheck. Let's work through an example. Say a thermometer reads 101 degrees Fahrenheit. Subtract 32 to get 69, then multiply by 5/9. This will give you about 38.3 degrees Celsius, a mild fever, which makes sense. Going the other way, suppose the chart says 38 degrees Celsius. Multiply by 9/5 to get 68.4, then add 32, which gives 100.4 degrees Fahrenheit. Again, that's a reasonable fever reading. The two formulas are mirror images of each other. Subtract then multiply in one direction, multiply then add in the other. Write the formula down each time until it becomes automatic. Next is weight, pounds and kilograms, which you will use constantly because many medications are dosed by the patient's weight in kilograms, while patients usually know their weight in pounds. The relationship to remember is that 1 kilogram equals about 2.2 pounds. So to convert pounds to kilograms, divide by 2.2. To convert kilograms to pounds, multiply by 2.2. Notice which direction is which. A kilogram is heavier than a pound, so the number of kilograms is always smaller than the number of pounds for the same person. That is your built-in sanity check. Let's try one. A patient weighs 154 pounds. Divide by 2.2 and you get 70 kilograms. Going back, 70 kilograms times 2.2 returns us to 154 pounds. For a quick estimate without a calculator, you can roughly halve the pounds and shave off a little, since dividing by 2.2 is close to dividing by 2. Whichever method works for you, label your units and confirm the kilogram value is the smaller number. When a dose depends on this weight, that small check is well worth the second it takes. Now let's move within the metric system, specifically milligrams and grams. The metric system is built on powers of 10, which makes it easy to use once you see the pattern. The key relationship here is that 1 gram equals 1,000 milligrams. So to convert grams to milligrams, multiply by 1,000. To convert milligrams to grams, divide by 1,000. Because the factor is 1,000, converting is really just moving the decimal point 3 places. Going to the smaller unit, milligrams, move the decimal point 3 places to the right. Going to the larger unit, grams, move it 3 places to the left. For example, 500 milligrams equals 0.5 grams, and 0.25 grams equals 250 milligrams. It helps to picture the metric ladder shown here at the bottom. Kilograms, then grams, then milligrams, then micrograms, each step a factor of 1,000. Move down the ladder towards smaller units and you multiply. Move up toward larger units and you divide. One safety note that we will return to, because these conversions hinge on the decimal point, a misplaced decimal changes the amount by a factor of 10 or more, so always double check decimal placement and always write a 0 before a leading decimal point, like 0.5, not just 0.5. Now for volume, where you will see milliliters, cc's, and drops. The easiest fact first. 1 milliliter equals 1 cc. They are exactly the same volume. The abbreviation cc stands for cubic centimeter, and you can read milliliters as cc's interchangeably, though milliliter is the preferred modern term. Drops are a little bit different. A drop, abbreviated lowercase gtt, is a unit of volume, but the size of a drop depends on the device delivering it. For intravenous tubing, the package states a drop factor, which is the number of drops it takes to make 1 milliliter, written as drops per ml. Common macrodrip tubing delivers 10, 15, or 20 drops per milliliter, while microdrip tubing delivers 60 drops per milliliter. To convert drops to milliliters, divide the number of drops by the drop factor. For example, with a 15 drop per milliliter set, 30 drops equals 30 divided by 15, which is 2 milliliters. The important habit is to always check the drop factor printed on the tubing because using the wrong one will throw off the volume. And remember, you cannot give part of a drop, so drop counts are whole numbers. Luckily, for medical assistants, we don't deal with IV setups, so drops typically aren't a problem for us. Now, length. Centimeters and inches, which you'll use for height and for measuring things like wounds. The exact relationship, defined by national standards, is that 1 inch equals 2.54 centimeters. To convert inches to centimeters, multiply by 2.54. To convert centimeters to inches, divide by 2.54. As always, think about the direction. A centimeter is smaller than an inch, so a length in centimeters will be a larger number than the same length in inches. Let's work an example with a common height. Suppose a patient is 180 centimeters tall. Divide by 2.54 and you get about 70.9 inches. Going the other way, multiplying an inch value by 2.54 gives centimeters. The ruler shown here lines up centimeters and inches, so you can see that 2.54 centimeters fits into 1 inch. Keep the factor 2.54 firmly in mind since it is exact and never changes, and decide multiply or divide based on which unit is larger. Sometimes you will record a height in total inches, but need to express it as feet in inches, the way most patients describe themselves. The relationship is simple. 12 inches equals 1 foot. To convert total inches to feet in inches, divide the total by 12. The whole number part is the number of feet, and the remainder is the leftover inches. So let's do an example. A patient measures 70 inches. Divide 70 by 12. 12 goes into 70 5 times, since 5 times 12 is 60, and that leaves a remainder of 10. So 70 inches is 5 feet 10 inches. Let's try another one. 65 inches. 12 goes into 65 5 times, which is 60, with 5 left over. So 65 inches is 5 feet 5 inches. The bar shown here breaks 70 inches into 5 full feet plus 10 remaining inches, so you can see the idea. The key is to keep the feet as a whole number and put whatever is left into inches. Do not write the remainder as a decimal of a foot unless that is specifically what is asked. Before we summarize, let's highlight the mistakes that cause the most trouble so you can avoid them. The biggest one by far is the decimal point. Because metric conversions move the decimal, a single misplaced digit can change an amount tenfold or more, which is dangerous with medications. Two simple habits prevent most decimal errors. Always write a leading zero before a decimal, such as 0.5 milligrams, and never leave a trailing zero after a decimal, such as writing 2 milligrams rather than 2.0, which can be misread as 20. The second common error is choosing the wrong operation, multiplying when you should divide, and vice versa. This is exactly why we estimate. If your answer is way too big or too small for what you expect, you probably flipped the operation. Third, always carry your units through the problem and label the final answer because a number without a unit is meaningless and easy to misuse. Fourth, do not round too early. Keep the full number until the final step, then round as your setting requires. Finally, when a calculation feeds a medication dose, follow your facility's policy and have it double checked. Careful habits, not speed, are what keep these conversions safe. Now let's summarize. Every conversion comes down to a known factor and a decision to multiply or divide, so label your units and estimate to check. For temperature, Fahrenheit to Celsius is subtract 32, then multiply by 5 over 9, and Celsius to Fahrenheit is multiply by 9 over 5, then add 32. 37 degrees Celsius equals 98.6 degrees Fahrenheit. Use this as your anchor. For weight, 1 kilogram is about 2.2 pounds. So divide pounds by 2.2 and multiply kilograms by 2.2. For mass, 1 gram is 1,000 milligrams, which is just moving the decimal 3 places. For volume, 1 milliliter equals 1 cc, and drops convert to milliliters by dividing the drop factor printed on the tubing. For length, 1 inch is 2.54 centimeters, and 12 inches makes a foot. Above all, guard the decimal point, keep your units attached, sanity check every answer, and when a result feeds a dose, follow policy and have it verified. Practice these until they feel routine, and you will handle the math of patient care quickly and safely. Here are your references for this lecture.